All right, so today we are going to go through the Responsible AI dashboard, and this is kind of what the end result is going to look like, but I'm going to show you how to get here. We're going to be using a data set today, just to talk about it very quickly. It's the diabetes 130 U.S. hospitals for the years 1999 to 2008. The point of this data set is to determine the early readmission of a patient within 30 days of discharge. So we're looking at patients that have been in the hospital already, and we're trying to figure out if they're going to be readmitted to the hospital in the next 30 days. And if you've worked with the diabetes data set before, this one may look a little bit different because we actually have, instead of having like the normal diabetes we work with, where all the features have been run through a PCA, these we're actually going to get the data out of them. So we have like encounter ID, patient number, race, gender, age, weight, admission type, etc. And I'm going to put a link to this UCI repo in the comments of the video also. And this is what the end result will be once we get done with the video today. And I'm going to give you several examples. I'm going to share a link to this RAI hack also. This is my repo. You'll see that I do have some sample notebooks out here, so you can take advantage of these. We've actually got a diabetes one, which we're going to demo today, education, finance, healthcare. Now, there is another repo under Azure examples that I would encourage you to look at. If you go to the Responsible AI Accelerator, this is a GitHub repo that goes to Azure examples. And you'll see out here that if you have something other than tabular data like text or vision, they actually do have some samples on how to do text or vision as well. And if you go through, you can actually see, which types of models they have out here for regression, classification, etc., decision making, and so on and so forth. So you can go through and take a look at this, and you'll notice that one of the things we're going to be talking about today is which RAI components are included, like explanation, error analysis, and counterfactual. But I'll give you the RAI link in this as well, so you'll be able to go browse around. And if you're interested in responsible AI in general, we actually have some more information in this repo about Microsoft's framework for building AI systems responsibly, the maturity model, the assessment guide, and the assessment template. So if you have customers or start asking questions about what are you doing about RAI, this is a good guide to get you thinking about it. We don't tell you how to do RAI necessarily, but we try and give you some guidelines to start thinking about it, because RAI is different to each company depending on the problem they're trying to solve, and it's going to be different in each country as well, depending on where you're at. So with that, we're going to go ahead and get started with going through this. Okay, so I'm going to assume that you have an Azure Machine Learning workspace already set up. That is kind of a prerequisite for this. There is a version of the RAI dashboard that lives outside of Azure Machine Learning. I will share that. That is in my repo. It's in the RAI toolbox, actually. So if you were to go down to the RAI Responsible AI toolbox and go out to this, these are the open source components that actually make up the RAI dashboard. So if you want to get more details about how this dashboard works and what these packages are, if you go down in the Responsible AI toolbox, you'll see that we have error analysis, fair learn, interpretML, DICE, EconoML, and Responsible AI for data balance. You can dive into each one of these packages and figure out more about them, how they work. And you can actually take a copy of one of these notebooks and run this outside of an Azure Machine Learning compute instance. So that is available to you. You will have to have a Jupyter server for this to run on. That is the one requirement, is that a Jupyter server. You have to run it even if it's on your own Jupyter server. That's where it needs to work. For Azure Machine Learning, we fully integrated it into the workspace, so you don't need to worry about that. But what we're actually going to start with is our compute. And because I've got basically a compute instance stood up where I actually have access to Jupyter Lab, Jupyter, VS Code Web, etc. So, and we're going to be using Jupyter today. So I'm going to assume that you have a compute set up already and you've got Jupyter running. And it actually does make your life a little bit easier if you set this up with Azure Machine Learning compute instance, just because of the packages that are required. So I'm going to go into the RAI hack, which is my repo. I've already cloned my repo, and if you need to clone a repo into this, basically what you can do is go into terminal, just do a drop down on new, go into terminal. This will give you a terminal session in your Azure Machine Learning compute instance. Go to the directory where you want to do it and just run your git clone from here, and then it will show up under wherever you decide to put it. I typically put all my stuff under my name in case I end up sharing my workspace with somebody else. So we're going to go to notebooks. We're going to talk about the diabetes story today. You'll see I've already got it set up and running out here. And this will load your notebook so you can take a look at it. The link, there is some more information about this particular notebook and about how the decisions were made and all the pieces came together. And I'm going to share this. This is in the RAI hack repo as well, but there is a getting started with Azure Machine Learning Responsible AI components. Super fond of this particular blog post. It's an 8-part blog post. It's really long, but it goes into detail if you'd rather actually read the text and go through there. So I'll share this link as well. I know we've got like 3 or 4 links I need to share with you already. They all are in the RAI hack repo, but I'll put them in the comments or the description as well so you can get to this. But we're going to walk you through this. Basically, this is going to be a video series of what Ruth did for this particular blog post, which I'm really fond of. So we're going to go back. So what we're going to do now, we've actually got this set up already. I've already run this several times, so it's not too big of a deal. And we'll just kind of walk through the different parts. I'm not going to spend all this time reading Python to you, but what you can do is actually just come in here and do a run all. And this will actually set up the compute instance for you. It will run all the Python for you. It will create train a model for you. And it will register the model and then create the RAI dashboard. So now that this is running, what I want to show you is how you can monitor this, because you're monitoring it from here can be a little bit of a beatdown. Because when you go through this, it's going to take about 30 minutes for this dashboard to run. So it is going to take a little bit of time, so be prepared for that. And you can monitor it here because it's got some feedback when you go through here, that says it is running, so you can keep an eye on it as it's going through there. But it's kind of boring just to watch the word running go by every once in a while. And actually, it's going to be this section's doing the training. This particular command right here, training job, submit and wait. So what's going to happen while it's training, this will take anywhere, depending on if it has to create compute or start compute, it basically takes some time. Now, when this is running, it's not using the compute you created here. It's actually going to be using a compute cluster. And you'll see that I actually have a responsible AI cluster that I've already created, and it is in the notebook that it will create it for you if it doesn't exist. And if you feel like you need to change the size, you can actually change it in the Python code. So you can keep an eye on this and see that, this thing is provisioning right now, that it's getting ready to run. It's running on 1 node, and I've got 3 more nodes available if I need them. What I like about this is you can also go to jobs under compute and see what's running on your job or on your compute instance. So I can click on this and get some, a little bit of information. But another place that I'd probably rather go is to jobs. And it's actually what it's doing. It's creating an Azure Machine Learning pipeline. So this is the job that I just created. And this is going to be the first one we're going to look at. And we'll see that, it's going to be tracking it. And you can see that you can monitor the pipeline from here. And if there's an error in the pipeline, you can get to the metrics from this. And you'll see this one's already completed, so there's nothing for me to do. But you can also get to the output. If there were any problems in the job or you need to do some troubleshooting, you can go to outputs and logs, and it'll give you the logs from this particular job as it goes through. Because sometimes you can get into a situation where if you put something in there incorrectly, the pipeline job will fail, and this is where you'll go to see what actually went wrong with my job. And it gets more complicated as it goes through this. So one that I've already run is this hospital classification RAI Insights. This is one that I ran a little while ago. So I can go out here and look at this and see that this one completed. So once the training is complete, it's going to go through and create the responsible AI dashboard. So this pipeline is a little bit more complicated. And this is where you may want to come in and keep an eye on this just to make sure that none of these components are failing. Because all you're going to see from your Python notebook is that, this is running, but you're not going to know in which part of the notebook or which part of the pipeline is it actually running in. And then you can drill in same way here and look at the outputs and logs and see what actually happened as it goes through there. Since this one ran without any errors, I shouldn't have any code that really came back out here or any errors that came out of it. But to show you what a failed one looks like, let me see if I can't find one that I actually have to go back a little while. Not that one. That one worked. Let's look at that one. See if we find one. Nope, that one completed. I'm going to need to find you a failed run right quick, because it can be important for you to figure out why did it actually fail. And it looks like these all completed. I know I've got some failed jobs out here somewhere. Let's go find one. You can see I've run this a few times. Let's go back to the beginning. Hospital. Let's try that one. Failed. So this is a good one to take a look at. So what you're going to get is you'll see here that the REI Insights dashboard constructor failed. So this is one where you might want to go in here and do some troubleshooting on this to figure out what happened. Now, what it's going to say is the pipeline has failed, and it's going to say go look at a child job. So if you look at child jobs, you can come out here and look at create REI job, and then you'll get some more details in here. Could not resolve a URL of an asset. So in this case, I actually put the wrong model, environment in there. Which brings up another point, is what is an environment that we're using? So for these to run, even though we're using compute clusters, it's still pulling in an environment into the pipeline, which means we have to specify which environment, Azure Machine Learning environment, do we want to use. These environments get updated, and this actually could cause a problem that if you basically create this and come back in a year and try and run it again, it may very well fail. Because as you well know, packages get updated, packages change, NumPy gets changed, scikit-learn gets changed, pandas gets changed over time. You could run into a situation where the environment you're running is no longer compatible with the packages. The code is it's not going to work anymore. It's no longer compatible with the Azure Machine Learning APIs. Because we have to update our stuff in Azure, and you're going to have to update things in yours as well. So then the question becomes, how do I find this? Well, actually, it's really simple. We actually have the environments out here on the blade on the left. And if we look at this, you'll see that we actually do have environments that you can choose from. So in this case, I'm actually using this environment, this Responsible AI Ubuntu Pi38C42. And to get the URL to where that thing goes, you can copy it from the asset ID, and then that would actually go directly into here. That's where you would paste that. And this is in here twice, so you have to look for it in two separate places. Otherwise, you get basically you get a dependency problem with what created the model, and then with Responsible AI coming in trying to test the model, it's going to fail. That's probably the biggest problem I've seen with any of these notebooks, is making sure the environments are set up correctly. So that's what I would look for. And this is kind of like more deeper troubleshooting than probably what you're going to need, because I'm going to try really hard to keep these notebooks up to date so you don't have to worry too much about it. But we'll see that if we look at our diabetes, the training job did complete when I go down here, and now it's running the REI section, the Responsible AI. So if we go back and look at the jobs, we'll see that this is running, and you can monitor it and just keep an eye on it and see where am I in the process. And you'll see the dashboard constructor has been completed. Now, when all this is done, this is kind of where the what you really want to know. It's like I go through all the trouble. I got the Python, I got my code, I got my data, I got everything solid, and my dashboard's complete. Where's the dashboard live? Easiest place to go look for the dashboard is going to be under the models. And so you can click on a model that's been created out here, and you'll notice that it is an MLflow model. The dashboard will work for AutoML models as well as MLflow models, and we should have samples for all of that out there. And then when you go into the model, you'll see that you have the details, versions, artifacts, endpoints, etc. And then there's a tab called Responsible AI. And in this case, there's three components of Responsible AI that we're going to look at: error analysis, causal analysis, counterfactual. So we're going to drill into the REI dashboard. And the first thing that it's going to do is you're going to see that it's going to connect this dashboard to my running compute instance where I'm running Jupyter. Reason for that, for the dashboard to be fully functional, it needs a little bit of compute on the back end. You can browse the dashboard and you can mess with it a little bit, but you really do need a compute instance to go through and look at this. And the first thing that we're going to start looking at is going to be the error analysis. This takes about 60 seconds to connect, unless you have to start the server. Then it may take anywhere from 60 seconds to 6 or 7 minutes. So you just have to be patient while that's actually coming up. But the first thing we look at, and remember we're talking about the diabetes data set. So the diabetes data set is the one where we've had patients that were in the hospital for some period of time. We're trying to predict if they're going to be back in the hospital in the near future, in the next 30 days. Now, what we're looking at here is the test data set. So we're going to clear this out just a little bit so I can get some more real estate. Close that, that'll move up a little bit. But the first thing we have is the error analysis. So what we can look at over here is see that we had, and this is the test data set. This is not the training data set that was run through this. So we're actually looking at how did the model perform when we ran the test. We got 826 correct. We got 168 incorrect. And that's another reason I like this particular model is because, or this particular data set, is the fact that we have some errors that we can go do some exploration on. And you've got a metric on the left-hand side, so you can select, if you wanted to change this to be something else, you can change it to what your precision score was. You can change it to the recall score, since this is classification, the F1 score, and see how it did. I happen to like error rate because it gives me the ability to see where in the model did it actually do a bad job. And we can see that at the first node up here, we have 100% error coverage. And as we go down, we'll see that this particular node made up 55% of the error coverage. This made up 44% of the error coverage. So we could go down either one of these paths. 42% of the error coverage, 10%, 31. Let's see if we can find a good one. This one's pretty good at 31%. How bad was that one? 29% of the total errors came from that node. So this gives you the ability to do more than just figure out what your error coverage was. When you click on one of these, it's going to tell you the decision, the prediction path it used to get to this. And the first thing that we see is the prior inpatient is at the top. So if we had a prior inpatient that was less than or equal to 0, well, we can't have a prior inpatient of less than 0, so we can figure out that the prior inpatient actually was 0. Number of diagnoses greater than 6, and then the number of lab procedures less than 52. Okay, so that's interesting. Let's go on this other side and take a look at it. So in this case, prior inpatient greater than 0, number of medications greater than 11, number of medications, okay, in this case, it's going to be medications between 11 and 21. And we can drill through this and create, different trees as we want to go through here to see basically the prediction path on the right of how did we actually do and what was the prediction path. Now, the other interesting thing is we have the ability to do a save as new cohort. So I'm going to call this cohort highest error. We're going to save this cohort and we're going to switch to it. So what this is going to now do is take the cohort we just saved where we had the prediction path prior inpatient equal to 0, number of diagnoses and number of lab procedures, and now we can drill even deeper. So we see that this made up for 54% of the total errors, and the error this made up for 43%. So then we can drill down a little bit farther if we want to and see how we actually did here. Number of procedures less than or equal to 0. So what we know so far about this data set where we're missing some of the values is that we had a prediction path of a prior inpatient of 0, number of procedures 0, lab procedures between 21 and 42, which seems like an awful lot to me. But then you kind of start seeing basically some interesting things with the data. I mean, we haven't gotten any farther than just the error analysis, but one of the things that becomes kind of obvious right now is the fact that if we have a prior inpatient of 0, we're actually having a hard time figuring out are they actually doing a good job or not. So we're going to go back to the all data and look at this again, and we're going to click on this. So this made up, this particular prediction path made up for 55% of the errors, prior inpatient 0. This one, we had a prior inpatient of greater than 0, but I don't know if we had any other prediction paths related to prior inpatient. So you can browse around here and actually see how they come out. But anyway, so this is good. You do have the ability to come in here and do a heat map as well. So we're going to leave this view and go to heat map. The heat map actually gives you the ability to compare features to each other. So we could come down here and say, I want to look at prior inpatient and see how we actually did based on, so it'll add prior inpatient. So what we can actually see here is the error rates for each one of these. So we had a 15% error rate for prior inpatient, and that's kind of an interesting. So I don't know the exact one. There we go, we got it right. So we had up to 9. But we can see that if we had prior inpatient of 13, we got 94 out of 94 incorrect out of, actually it's more than 622. It's around 710 or so. But that made up 55% of the errors. And as we go higher, we see that the error rate gets a little bit better. So what this is starting to tell us is the more we know about the patients, the more likely we are. If they were a prior inpatient, the more likely we are to be able to predict if they are going to be a future inpatient. And then you can also add this by another if you wanted to, like, race, gender, age, discharge destination, time in hospital, and it'll actually create a little grid for you. So you could actually do it by, let's say, number of lab procedures. So that one's going to be a little bit of a busy chart, but you could say, the number of lab procedures that we have at the bottom with the prior inpatient on the left, so you can actually start figuring out. But take a look at this. Just because you miss 50% of them doesn't mean the model's off by 50%. It's like in this case, we had one person that had between 49 and 59 lab procedures that had been in 6 times. So that was just one of those individuals. So you can do some data exploration, which you're going to see throughout this dashboard. You have the ability to do a lot of data exploration. Okay, so we're going to clear everything and go back. We still have our cohort out here of the highest error that we're going to focus on for the rest of this dashboard. But what we're going to do now is scroll down to the next section, which is going to be the model overview. So what we have here is the basically the temporary cohort. Let me show you what that is. If I click on, let's say, this particular branch, what that's going to do is add a temporary cohort down here that's going to change dynamically with whatever I do here. So I could click on one of these tree nodes, and it's going to change the temporary cohort to be whatever that is. So if you just wanted to do some exploration to figure out what's my sample size, the accuracy score, false positive rate, false negative rate, and selection rate, you can actually come down and do this. So in this case, what we're really going to be focusing on is all the data in the highest error, which the highest error made up for about 249 instances. And we had an accuracy score of 0.78, which isn't terrible compared to the high data. But the problem is, one of the things you have to think about is when you're looking at this is the confusion matrix. Can I use accuracy score as a metric when I'm looking at this data set? So to answer that question, you need to go to your confusion matrix, and we're going to show this a little bit, and I'm going to show you what it looks like right here. And in this confusion matrix, you have to pay attention to it because sometimes some products will flip them. So you have to make sure you're focusing on the one you're looking at, not what you remember from your stats class necessarily, or how R does it or how MATLAB does it. But in this case, it actually does a good job. So we got 802 data points should not be readmitted, and they predicted they would not be readmitted, which means that we got those right. So that would be a true positive. We got this one wrong, which we predicted they would be readmitted, and they were readmitted, and that would be, actually I got it backwards there. So that would, readmitted would be a true positive, and this would be a true negative. So we got these two correct. That's how those show up. The problem is, since our true positives and our true negatives are imbalanced by that much, we can't use precision as our score, and which means we can't use accuracy either. So what we have to take a look at is F1 score. So we're going to add our F1 score and see how we did. And you'll notice that kind of takes everything a little sideways. What happens here is our F1 score on all the data goes to 0.22, and on the highest error data set, our F1 score goes to 0 for that. So that's obviously going to be a problem. Now what that tells me is if the F1 score is 0, that means we have one of these boxes is going to be a 0 also. So let's take a look at that. In fact, two of them are. Because F1 score is the harmonic mean of precision and recall, and if you end up with a 0 in your F1 score, that means that one of the values you use to calculate precision or recall is going to be a 0. So we got 196 right, and the readmitted, we got all 53 of them incorrect. So that's going to be a problem. So we're going to need to think about that some more. But one of the things we already know about this from going back up to our highest error, if we look on this, which is where we saved it, and we can actually switch our cohort. If we go back to this, one thing we already know is if we don't have history on a patient, because in this case what got us here was prior inpatient is equal to 0. If we don't have any history on the patient, we're doing a really bad job of predicting if they're going to come back into the hospital again. So we already kind of have a very good answer, a very good understanding of what's going on with this model. Now the next thing is, when this is the hard part about being a data scientist, is there any other data that can actually help us figure out, will this person be readmitted in the near future? And that's something that, that's why data science is a hard job, is because when you start finding out you don't have history on a patient, you may, have to find some other variables to figure that out, or you may have to put a warning that if we don't have prior history, maybe we're just not doing a good job. It's kind of like the first time you log into a new video streaming service. What do they recommend the first time you ever log into a streaming service if they have no history on you? You're kind of running into the same problem here. But anyway, so you can go through this. You can look at the confusion matrix from the highest error and from the temporary cohort, as well as the all data. And you've also got the metrics visualizations if you want to look at this. So you can check out the accuracy score or choose this to F1 score to see how this thing does. And you can see that on the temporary cohort, which right now the temporary cohort and the highest error is the same data set. So we can move that to, let's do a switch cohort. Come back, go to all data, apply. And we'll change temporary cohort to like this bunch over here, which makes up 29%. And we can see that we did a pretty bad job on the F1 score on that one too. And this is just a metrics visualization to show you a different way of looking at it. And then probability distribution, which could be interesting. The probability of not being readmitted. which you can change that if the not logic is confusing you a little bit. Determine what's the probability of being readmitted. And among the highest error, the probability of being readmitted overall is pretty low. But when you look at all data, that's a little bit higher. And the temporary cohort I have selected, it does a little bit better. So you can get a probability, but then you can drill into the outliers as well. And I'm going to show you here very quickly in the next section of this how we can actually go through and take a look at individual data points if you want to do some exploration there as well. So in this, if we look at this right now, we have the cohort that we have selected as the highest. Let's go back. Make sure that works. There we go. So this is we've got the all data cohort. You'll notice that when I switch this cohort up here, it affects the entire page. So keep that in mind. If you end up saving 4 or 5 different of these cohorts, which you do have the ability to save several cohorts based on your data analysis, you could even come in here. Actually, that won't let you do it there. But if you go in and do feature cohorts, we do need to look at this real quick. Feature cohorts for model overview. So we're going to select, let's see here, temporary cohort. Data cohorts. All right, so metrics visualization, choose cohorts. We got that. Feature cohorts. Let me choose features. Select features. Here we go. I'm looking right at it. So we're going to take prior inpatient, for instance, prior inpatient, and we're just going to save that one. So now we can actually see another way of actually looking at the feature cohorts to see how they actually are set up. We could come in here and add something like time in hospital as well. And it will add that so you have 2 variables to look at. You have the prior inpatient less than 3 and time in hospital less than 5. And it tells you the sample size for what you are and how you did on the accuracy. So in this case, it gives you a little bit, or in this case, the F1 score. So it gives you a better idea. So you can kind of slice and dice the, let's say, number of that. We can actually look at the admission source, which I think there's only a couple admission sources. There's a few out there. Because an admission source, you'll have to look at the diabetes data set from the UCI to figure out what exactly that is. But then you can start seeing, is there a pattern in the ones that we're missing in addition to prior inpatient? And would those be valuable to figure out from looking at more data or different data? Now, this one, the fairness metrics, what we're looking at here is it's a sample size, which is the largest sample size, and then subtracted to the one sample size, and the difference is going to be 879. So that's where these 2 numbers come from at the bottom, and then you can kind of look at, what's the score on these on the difference. But this is going to take a lot of time to do some exploration. It's not like you're going to be able to come in here and, in 5 minutes figuring out every single thing that's wrong with your model, because we have a relatively easy, data set to look at. Metrics visualizations, we looked at this. Confusion matrix, we looked at that. So now we're going to look at the data analysis. So in this case, I've actually got the cohort that I've got selected as the highest error. So I'm going to stay in that cohort. Correct predictions was 196, and then we've actually got the ones that we got incorrect under incorrect predictions. So we can actually start looking at the data. Now, typically for data scientists and analysts, you will have done what I'm going to show you already before you ever created your first model. So what I like to do in this case is you have the ability to do data exploration. So in this case, we've got race on one side. We're going to put on the bottom, we're going to use something else from the data set, do prior inpatient, and just see if anything shows up. And we'll see that, the data we've had of the prior ones that African American 15, was blue 15, Caucasian was 65. So this can help. It's just data exploration that you typically would have done anyway. So you can slice and dice this data however you want. You can change other columns. But my experience with data science and machine learning is the fact that you'll normally get all of these done, your data exploration, before you ever create your first model. So you probably have a Python notebook, or you've got a Power BI dashboard, or you've got an R script or something somewhere where you've already done some data exploration. This gives you the ability to do it after the fact on the cohort that you're failing on. So you have the ability to do this inside this as well, which I think this is, I think it's really kind of interesting that we have this. And this is the temporary cohort, so we could change it to the highest error and see that. But all of the data shows up. You'll see that basically for prior inpatient, we show A1C result. Now it's kind of boring. Let's go back and do a different one. Number of procedures, prior inpatient number of procedures. Yeah, we'll see that they didn't have that many procedures on them. So you can slice and dice the data based on the cohort that's got the highest error rate as well. Feature importance, you should be familiar with this if you've ever messed with Python or R. So basically this will tell you that this is the aggregate what they call the top K important features that impact your overall model predictions, using a also known as global explanation. So you're used to this. You've seen it before. We kind of figured out already that prior inpatient was probably the most important one just because of the decisions that this model was making. What's interesting here is I can go into individual feature importance. All right, so we are going to select a row for this. It's going to be row 986. You'll see that the feature importance plot does come up, and as we expected, prior inpatient was the most important feature that's showing up here. Now, and you can choose different rows to see if there's anything, and you can compare a few of these rows to see if there's any difference between many of these, and you'll see that prior inpatient comes up pretty often. Now, the other thing we can do is we're going to do an ICE, individual conditional expectation. So what that's going to show us, and I've still got, in this case, I've got predicted probability class not readmitted by prior inpatient. The likelihood of not being readmitted is about 0.87 based on 0. And you'll notice as your probability of not being readmitted increases, and we can change that, I think. See if it'll let us. I don't think it will let us change it. But yeah, since that's the thing we're trying to predict, the more prior inpatient experience we have with you, the higher likelihood that you're going to be readmitted, which means your not readmission is going to be a very low score. So this kind of gives you the ability to take a look at this and see, with different features, does it make any difference? Does time in hospital have any impact on that? The more time you have in hospital, the higher the probability of not readmitted. That seems kind of backwards to me. Maybe that's a good thing or a bad thing because they just got out of the hospital. But we can also look at admission source to see if that has any impact on it as well, which we'll need to dig in to see what admission source was. But if you look between the bottom and top of that, it's only about 84 to 88%. So that's a pretty low. It's only about a 0.4%, 0.04 or 4% difference between the lowest and the highest score for admission source. So. Okay, the next section of the dashboard as we go down is the counterfactuals. So I'm going to switch cohort and make sure I'm looking at all the data. And what I'm going to do here is, and I'll show you what counterfactuals mean in a second, but what I want to do first is I'm going to turn this into sort of a scatterplot confusion matrix, and you'll understand what I mean. So we've got predicted Y and true Y. And what this gives me the ability to do is see where, and you'll notice it does look kind of like a confusion matrix, but what I'm trying to figure out is I want to focus on the rows that I missed. So in the lower left, you'll see that the true Y was not readmitted, the predicted Y was not readmitted. We got those right. The upper right is true Y was readmitted, we predicted they would be readmitted. So we got those correct also. What I want to look at is the ones where we got them wrong. And specifically, I want to focus on this bunch over here, where we've actually said the true Y was they were readmitted. We predicted they would not be readmitted. So what we can now do is run a counterfactual what if. So this is our reference point right here, row 908. This is the value. Predicted value was not readmitted. They actually were readmitted, so we need to figure out what happened. Now what the counterfactual does is gives you the ability to change a value to see if it would actually have an impact on the model behaving differently. So we could come in here and say, let's just change the prior inpatient to 1, and it doesn't make any difference. We'll change it to 2, it doesn't make any difference. We change it to 3, it doesn't make any difference. We change it to 4, suddenly it makes a difference. So that's more that you actually, more things you can actually do. So all I have to do is go back to this is our ground truth up here, set the value. It'll reset this at the bottom. And there are some that that it creates for you where you can actually say prior inpatient 14 number, or in this case, prior inpatient 14 number of medications 15, admission source 17. So it gives you some rows, like test rows to play around with. So you can actually experiment and see how big of an impact does a single thing make. You can set a counterfactual to be one of these where Medicaid is false, prior inpatient is 2, but the number of medications is 81. Which seems rather high. So we can go back and set that value to the reference ground truth default, and number of cases is back to 12, which makes me curious. If I were to set that to 81, would that make a difference? In this case, it didn't, but prior inpatient of 1. Actually, those two. Let's see, what was the other one? They didn't change Medicaid. Prior emergency, change that to 1. was trying to replicate that row. So yeah, that combination of these three right there actually were enough to influence the model's behavior. So the counterfactual gives you the ability to basically experiment with, what if I were to change a single value in one of these rows, or change 3 or 4 values together? Would that actually have an impact on the prediction path? So that's kind of where those are. The top rank features for row 908, so you can actually come in here and see, like for the row that I have selected, what were the most important features for row 908 to achieve the desired model prediction. In this case, Medicaid, prior inpatient, number of medications were how they actually came out. Now, causal analysis, this trips up some people that didn't start their life in R, or if they haven't in Python looked at effective estimates, standard errors, p-values, or confidence intervals. I started in R. Let me show you what that looks like. I started my life in statistics using R. So I got used to, in the early days, learning how to interpret a model based on the estimate, the intercept, and the coefficients that came out of the model. With Python, a lot of people have gotten into the habit of basically just dumping the data into the model, doing feature importance, and running on with life. But you actually do have the ability in R to go through and take a look at this and coefficient plots, where you could actually take a value of a coefficient, put it on a bar to see where did it actually fall on a line based on 0. And some of the values will have obviously a negative, some of the values will have a positive. Where do they fall on a plot when you're actually looking at the different values? There was an argument, and I'm not saying this is true or that you should do this, but there was an argument among some professors when I was in school that said that any of the values that approached 0 probably weren't that valuable to the model unless you were multiplying them by extremely large numbers, which is something you have to think about. So this is kind of where I started. Now, if we look at the causal analysis, this is what these numbers are. So we can actually go out here and see the effective estimate, the standard error, the z-score, the p-value, if you're interested in that, confidence interval, upper and lower confidence interval for about 95%. And then at the bottom, we get this same coefficient plot that I was showing you in my R screen, where we can actually see the values that are approaching 0. So you have the ability to go in and take a look at these values, and you can add them. You have to add them individually. We don't create them for you. So if we were to go look at, scroll down to the bottom here, we actually see here that in one sections where we're creating the dashboard, the RAI classification pipeline, we actually had to create a causal job with the RAI causal component, with all of the what do I want to add to the causal analysis. So you have to add these manually. But those will get added in there, so you can take a look at them and check them out on a coefficient plot. And this is the thing. This is one more tool in your toolbox to figure out, how am I actually doing? How is the model actually performing? And then you have the individual what if, where you can take a look at just one of these and get, what was the effective estimate for that one individual. So if you want to explore that as well and troubleshoot a specific individual and how they're behaving. Treatment policy, this is another one. So we're going to look at treatment policy. So this one, let's see. Number of lab procedures, medications, number of diagnoses, prior inpatient. So this one's kind of interesting. What you would typically do with a treatment policy, and to give you an example of what you would be thinking of with a treatment policy, is if I were to send you a marketing email to buy a video game, and I were to not send you a marketing email to buy a video game, which one would be more effective? Me sending you one or me not sending you one? So the treatment policy would be to send you one. So it's kind of the same thing there. I was going to look and see what A1C is something we typically want pretty low. Actually, we don't have that in there. So you got prior outpatient time in hospital. So you can take a look at the treatment policy and basically average gains of alternative policies with no time in hospital, always treat, recommended policy gain. So if you have time in hospital, that shows you what the outcome for the treatment policy would actually be. And there is some information. So one of the things I haven't called out too often is we do have a blade on the right that actually tells you a little bit more about how the treatment policy would work. This is not one I'm super familiar with. I didn't cover it for very much in statistics. Once I got past hypothesis, I kind of moved on to machine learning. But it kind of gives you some information. So, keep an eye on the information we give you. And then also, on this, don't forget we actually do have documentation from the source packages that this stuff came out of.
So you can come down to basically the very package where this was created, causal analysis, counterfactual. So this is starting to look familiar now. Econ ML is where that came from. So there are some examples of how to go out that interpretability and how to get through it. And there are some samples you can run on your own as well, where you can actually dive into more of the treatment policies. Let's see here, Econ ML, detail package, go here. So you can dive pretty deep into the contents of this package to understand more about it. And that's with all of the packages we actually have. So, but hopefully this will help get you started. The packages, all of the notebooks that I have out here right now do work. And I'm going to try and keep a close eye on them to make sure we don't get into a situation where they start failing again. But we've also got the ones on Azure examples that are out there under responsible AI. So you can use those as well. Those are monitored. If they fail, there is somebody that actually will go out there and research why it's failing and get it fixed for you. So if you end up using Vision or text instead of tabular, you do have a resource, and I'll put those resources in the link. Hopefully you found this a little bit useful. I know this was kind of a long video, but this is about as fast as I can get through it, quite frankly, just because there's a lot of information to cover. But anyway, good luck with your dashboard. I hope you find it useful. I hope you found the video interesting. Keep an eye out for more videos from my team.